If you care about the hidden technologies that quietly kept people alive during the harshest decades of the Cold War, subscribe to this channel right now and share it with someone who still believes survival history is only about weapons and bunkers. Today, we're going deep into one of the most overlooked artifacts of civilian resilience, the Cold War heating brick that never froze. This is not trivia. This is applied survival engineering that worked in silence in apartments, military barracks, and remote outposts where failure was not an option. During the Cold War, survival was not defined by dramatic moments, but by endurance. Millions of people lived through winters where heating systems failed, fuel was rationed, and power outages were expected. In Eastern Europe and the Soviet Union, engineers were tasked with a brutal challenge. Create a heat source that could store warmth, release it slowly, and function even when electricity or fuel disappeared. The result was the thermal storage heating brick, sometimes called a heat accumulator brick, and it solved problems modern systems still struggle with. Why Cold War engineers needed a brick that could not freeze. The core problem was cold soak failure. Conventional radiators and water-based heating systems freeze when temperatures drop below zero and circulation stops. Once frozen, pipes burst and entire buildings become uninhabitable. Cold War planners assumed that infrastructure would fail, either from sabotage or simple overload. Heating bricks avoided liquids entirely. They were solid, dense ceramic or fireclay blocks designed to absorb enormous amounts of heat without cracking, then release it slowly over many hours. These bricks were often charged with heat during off-peak hours or brief periods of available power. Once heated, they required no further input. Even in unheated rooms at extreme sub-zero temperatures, the bricks themselves never froze because there was nothing inside them that could freeze. Heat stored in solid mass behaves differently from heat carried by water or air. This distinction is what made them reliable when everything else failed. So, let's talk about how the heating brick actually worked in practice. The bricks were, made from high-density ceramic, quite similar to what you'd find in kiln linings or the cores of industrial furnaces. These materials could absorb heat up to several hundred degrees Celsius without degrading at all. Inside a stove or storage heater, electrical elements or solid fuel would heat the bricks slowly and evenly. And once they were charged, vents and dampers would control just how fast the heat escaped into the room. Now, this wasn't radiant heat in the modern sense. It was really all about thermal inertia. The brick acted almost like a battery, but instead of storing electricity, it stored entropy. Even 12 to 24 hours after the heat source was removed, the brick would continue releasing warmth. That made it absolutely ideal for overnight heating, blackouts, or, fuel shortages. What made this system remarkable wasn't just efficiency on paper, but its predictability. Engineers could calculate exactly how long a charged brick would remain above a usable temperature. That kind of reliability really mattered in military housing, hospitals, and civilian apartment blocks, places where failure meant frostbite or, frankly, something worse. It's important to consider where these bricks were used and, why they truly mattered. In Cold War apartment buildings, especially in those Eastern Bloc cities, these bricks were integrated into massive tiled stoves or standalone storage heaters. In rural areas, they showed up in bunkhouses, rail depots and border facilities. They were also used in mobile field structures, where liquid fuel was scarce, but electricity or solid fuel could be accessed, even if only intermittently. The key advantage was decentralization. Unlike those big district heating systems, each unit could function independently. If a power station went down or fuel deliveries stopped, a building with charged bricks could actually stay habitable for days. This was passive resilience, not active defense, and it saved lives quietly, almost without anyone noticing. What modern survivalists can learn from this forgotten technology? Well, it's not about nostalgia. For serious survivalists, the lesson here is material science and system design. Thermal mass is honestly one of the most powerful tools for off-grid living. Modern homes, they rely heavily on active systems that fail quickly without power. Cold War heating bricks remind us that storing heat directly in solid materials is often more reliable than storing fuel or electricity. So, a practical modern application is, building a masonry heater or a thermal bench using firebrick or stone. You heat it just once per day with wood pellets or even solar-assisted electric elements, and then you simply let the mass do the work. In a grid-down scenario, this approach can drastically reduce fuel consumption while still maintaining survivable indoor temperatures. Another application is emergency preparedness. A single high-mass ceramic block, if heated safely, can act as a room stabilizer during those tough winter outages. If you wrap it properly and place it near sleeping areas, it can actually prevent hypothermia, without the risk of open flames. And this isn't just theory. It's the very same principle Cold War engineers trusted for, millions of people. Now, why did this technology disappear from mainstream use? The decline of heating bricks wasn't because they failed. Far from it. It was all about convenience. Central heating, cheap energy, and lightweight construction pretty much pushed thermal mass out of modern design. Efficiency metrics started to favour instant heat over stored heat. But, you see, instant systems collapse quickly when supply chains break. The Cold War brick, though, it did not. Today, as energy instability returns and resilience becomes, relevant again, this forgotten technology really deserves renewed attention. It's simple, durable, and brutally effective. It doesn't rely on software, sensors, or constant input. It just works. So, if this kind of deep survival history matters to you, subscribe to the Legacy of Survival channel, share this episode with someone who still thinks resilience is all about gadgets, and stick with us as we uncover the forgotten systems that quietly kept humanity alive when the world stood on the edge.